From my side, I can't see.
Hello guys, my name is Desmond and I welcome you to my lesson for today, where we'll be looking at your mathematics. Obviously, as you can see over there, ladies and gentlemen, we'll be looking at trigonometric functions. Very, very much important, ladies and gentlemen, over there. So guys, before I even go far, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively. Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Andrew, please, Samke, please make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So quickly, I want to take you guys through the stages of the trigonometric functions. So obviously, we do have multiple stages, but for the sake of today's lesson, let me maybe take you through a baby stage, a teenage stage, and then from there, let's say an adult stage. So I normally use these stages so that it's easy for you guys to remember. So ladies and gentlemen, obviously, you do know very well that we've got three trigonometric ratios. What are those? We've got sine, we've got cos, and we've got tan. So that is why we make use of these trigonometric ratios to draw the trigonometric functions. So here's the general formula. We know it as y, it's equals to, it could be a sine of angle, or otherwise y is equals to a cos of angle, or otherwise y is equals to tan angle. So this is how the trig function looks like in terms of its general formula at a baby stage. So you can maybe consider this to be grade 10 stuff. So grade 10s, all of you guys, when you get to a grade 11, let's just make an assumption that it gets more complicated, but it doesn't really get that much complicated. To be honest with you, they just add a over there, and I'm going to explain to you exactly what that a means. So we've got all of those trig ratios being added or being multiplied by a. So I'm just assuming that all of you guys, in grade 11, you are well aware that there's something called a, of which, without any waste of time, the a value, that a, we know very well that it represents what we call the amplitude. Remember, guys, what I'm doing in today's lesson is just to take you through an introduction to this chapter called trigonometry, specifically trigonometric functions. So on my previous lessons, I have been doing these, but not going deep. So in today's lesson, I'm just going to be focusing on these. And most importantly, don't stress that much about having to grab everything at once. It will make sense as I go deep, and also on upcoming lessons where I'll be taking you through, guys, exam type of question paper. So can you guys see in grade 11, it's more like when you get to grade 11 standard, that's where they'll introduce what we call an amplitude. Let's now get to this stage. So it doesn't really get that much complicated, guys. This is how it looks like for the sine graph. You still have a amplitude, sine of angle. They just add the q value. Similarly, for the cos function, they just add q. And also for this one of tan, we are having amplitude tan angle plus the q value over there. So this is that stage where you guys need to be aware of. So now let's maybe discuss the impact of that q value on our trig function. So the q value, it doesn't do much other than influencing the vertical shift. So what exactly are we talking about when we talk about the vertical shift? When something shifts vertically, that's when it shifts upwards or downwards. And obviously, if we have a positive q value, it means either this function of sine, cos, or tan has been shifted by whatever q values upwards. If it's negative q, it means the function has been shifted by whatever q values downwards. For example, if you've got that as a Cartesian plane and you've got a function doing something similar to that, if maybe, let's say, is y is equals to whatever, maybe plus 2. So it's more like it has been shifted by 2 units upwards, which means now the whole of this, you just take it and shift by 1, 2 units upwards, which means it might be now doing the waves over there. Or otherwise, if maybe it's negative 3 or minus 3, then it shifts by 1, 2, 3. So it is still the same thing, but we just shift it by 1, 2, 3. So you might find that now you have it doing that over there. So no need to worry that much about all of that. I am going to quickly sketch these functions so that you've got an idea of what we are dealing with over there. Maybe let me sketch these functions, the trig functions, at a baby stage. For example, let's firstly start with the function of y. It's equals to sine that, and they say sketch this where angle is the element of negative 360 degrees and 360 degrees. All of you guys, make sure you've got your calculators ready, and most importantly, make sure that it's in degree mode. Very much important, ladies and gentlemen, over there. So I'm not sure, before I start sketching our function, is there someone who's got a question before I go deep? Remember, in case if you've got no question, you can just make a comment to say no question. Then I'm aware that you did get my message. You don't have any questions.
No questions.
Question, sir.
No questions.
No
Okay.
questions, sir.
100%.
No
So now,
questions, sir.
this is what you do, or this is where you start when you sketch your function. So this is where you have a look at. Can you see they're saying where your angle is the element of a negative 360 to 360. So that means on your Cartesian plane, This line, which is well known as the x-axis, it is the one which is our angle over there. And then this vertical line, this is the one which is the y-axis. So that means you now need to have your critical values. I'm just not sure if I should teach you guys now or at a later stage in terms of how do you find your critical values. So what are the critical values? The critical values are those values that you must be writing there. Those are what we call the critical values. So it's more like the critical values are those values that must appear on your function. Or maybe let me just make you aware now. Is there someone who knows what is the period of that function of y is equals to sine angle? What is the period of that? Is there someone who knows or someone who can guess? Guys, are you still there? Remember, in case if you don't know, you can just say no idea, so that I'm aware that you did get my question, but you do not know. It's not a problem if you do not know, but just make sure that if there's something that you do not know, you make sure that you know it before we conclude our lesson. So the main importance of our lesson is for you to know what you did not know. So what is the period for a function of a sine angle? Y is equals to sine angle. Anyone who can guess, or do you guys know? Okay. I suppose someone was about to say no idea. Okay. So always, the period of the function of sine angle and cos angle is 360 degrees. And then the one for tan angle is 180 degrees. That information is on the notes. If you are writing, you can write it down to say the period for this is that the period for both of these is 360 degrees, and then for tan is 180 degrees. So I'm still going to explain that. So since we know what the period is for this function, you must divide it by 4 in order for you to get the critical value. Can you see? So it's more like CV is equals to P over 4. So now that I am saying the period for this function is 360 degrees, what is the critical value? Is there someone who can calculate using this formula that I've just given to you?
90 degrees, sir.
Sorry?
90 degrees. 90 degrees.
Yes, it's 90 degrees. So this 90 degrees, it means you must space your function in intervals of 90. So that means you are going to have 90 there. You add another 90. What are you having? Is it not 180? You add another 90. What are you having? Is it not 270? You add another 90. What are you having? Is it not 360? Remember, here they said start from negative 360 and end at 360. So that means we still have to do the same in that direction. Remember, here it's 0. here, what are we having? Is it not negative that? Is it not negative that? Remember, you just place it at 90. So this is what you are having over there. I'm not sure. Is everyone with me on that one? Are we still together there?
Yeah, it's correct.
Yes, sir.
Okay.
Yeah.
100%. So now, let's start to plot. This is what you do when you plot. You start from this side going to the right. So that means on that formula, you are just going to substitute all your critical values there in order for you to know the critical, what is it, the corresponding y value. So let's start. This is how you do it. Remember, your calculator must be in degree mode. You're just going to punch sine. What is the first angle? It is negative 360 degrees over there. What are we having? We have 0. So you make a point there where y is 0. So you go and edit that negative 360 and use the second value, which is 270. I'm getting 1. What are you guys getting? Are you also getting 1? If that is the case, you make a point over there. You go and edit there again, and you use the next critical value, which is negative 180 degrees. I'm getting 0. I'm not sure. Remember, guys, as I'm punching, you guys must be punching on your side. In case if you get a different answer, then ask why that would be the case. So can you see, for negative 90, I'm getting negative 1. For 0, I'm getting 0. So you just make a dot there. Let's see, for 90, remember, it's positive 90. I'm getting 1. What is it? Now we are on 180. So you just edit and punch 180. What are you guys getting there? You are getting a 0. Let's go to 270. What are you guys getting there? I'm getting negative 1. Let's go to 360. You just edit and punch 360. I'm getting 0. Guys, are you all getting the same values there?
Yes, sir. Yes, sir.
Okay. In that
Yes,
case,
sir.
that's how you plot. Now, let's sketch. So when you sketch, it's just a matter of you joining those dots. Can you guys see how nice this thing is? That's all that you do. You just join those points and then you form the function. So when we talk about the period, we are saying from negative 360 up to 360, this function, it does that shape, which is that. If we had to continue in that direction by adding 90 from that 360 and adding and adding and adding and adding and adding, it means this shape, it is going to repeat itself after every interval of 360. That's what we mean by the period. Maybe let me try use a different explanation to say, if you have a ruler, something similar to that, let's say it's 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. When we talk about the period, for example, it's more like we are saying, if I had to sign within there, and this is what I'm doing as I sign. So it's more like my signature has a period of 1 to 4. So that means the period of my signature is 4 centimeters or 4 millimeters, meaning if you add again, let's say 5, 6, 7, 8, then my signature was going to repeat exactly the same way after every interval of 4 units. That's what we mean by the interval. So that means if maybe you cut my signature there and you are only seeing this portion of my signature, this is not the period of my signature. The period of my signature, it starts from 1 up until 4. So for now, just remember that it will make perfect sense as we go deep with our functions. But for now, can someone confirm if this function of y is equals to sine angle makes sense, or is there someone who's being confused by something yana yana there, or are we all on the same page?
We're on the same page, sir.
Okay, then
Yeah,
in
we're
that
on the same page,
case,
sir.
let's try at the same time on the same set of axes. Sketch the function of y is equals to cos of angle, having that same interval. Notice something, guys. This one for sine, maybe let's say this is the one which is y is equals to a sine of angle. Something very, very much important. It makes it easy if maybe we assign a name to this function, maybe call it a g of x. Maybe let's call this one a f of x. Then instead of me having to write that lengthy equation, let's maybe say this is the one for g of x. Maybe let's quickly try to draw this one of f of x. We are just going to be the same, to be doing the same thing. We start from there, going in that direction. So let's punch. A cos of negative 360 degrees is equals to, I'm getting 1. There is 1. I'm going to edit now and then punch negative 270. I'm getting 0. So I just make a dot at 0. Let's go to the next one, which is what? Negative 180 degrees. I'm getting negative 1. You just make a dot there. Which one? The next one is negative 90. At negative 90, I'm getting 0 there. It is that 0 there. Where am I? I'm now on 0. Okay, 0. For 0, I'm getting 1, and there is 1. So now I'm on 90. I'm going to punch 90. I'm getting 0. I'm making a dot over there. The next one is 180. I'm getting negative 1. There is negative 1. And then now I'm on 270. It's equals to, I'm getting 0 over there. And then now I'm on this one of 360. I'm getting 1. And there it is 1 for this one of 360 there. So now we've made our points. Do you guys agree with me on that one?
Sir, yes, sir.
Last one to confirm.
Yes, sir.
Yes, sir.
Okay, 100%. So now when you sketch, it's just a matter of you connecting those dots. It's just a matter of you connecting those dots. Can you guys see these functions, guys? This is that one of f of x, the one for cos. Can you guys see how nice this thing is, guys? It's just a matter of you knowing that they say sketch it from a negative 360 to positive 360. So that means on your x-axis or on your horizontal line, the angle is going to start from negative that and that. Then you just punch those on your formula. But most importantly, you must know your critical values by using that formula over there. So I've always been using this to know by what spaces I must be having on that line. In case, for example, in case if examiner said sketch your function where your angle, it is the element of, let's say, negative 270 degrees and 180 degrees. So it's more like they're saying, we just want to see your function starting from there, ending from there. So can you see, this is the negative 270, this is positive 180. So it's more like they don't want to see this part, guys. Be careful of that. Be very, very careful of that. They just want to see it starting from negative 270 and ending here at 180. So that means when you sketch it, it just starts from there and then it ends there. I'm not sure. Am I not confusing you guys on that one? Can you just confirm?
No, no, sir.
No, sir.
No, sir.
Sir, that formula CV is equals to
P over 4.
negative
Sure.
P over 4. Yeah, grade 10 or grade 11. Now I'm confused.
Okay. Remember, Kabelo, let me say for now, nothing is for grade 10, 11, and 12. All that I'm saying is what you must know. For example, if you're in grade 11 and they say sketch this function, this is how you sketch it. But for you to know how to sketch it, this formula for calculating or for knowing the critical value, it helps you to know how to space or what are the values which are important, which should appear over there. I'm not sure if you're getting me on that one, Kabza. So it's more like there's no need for you to know whether this is for grade 10s, 11 or 12. It's for everyone to know. If I say it's for grade 12s only, that means how are you going to plot or how are you going to know in case if it's more complicated than that? I'm not sure. Do you guys understand my response to Gabelo's question there?
Okay. Yes, sir, I now
Yes.
understand.
So
Yes, sir.
yeah.
Yes.
So everything that I'm saying, guys, don't ask yourself if the info is for grade 10, 11, or 12. It's for everyone to know. The problem with that, Kabza, is that I'm just not sure in which grade you are, but for someone who's in grade, grade 12, for example, um, uh, if you say, I'm going to teach you maths and I'm going to teach you grade 10 maths, because it's for grade 10 and then grade 12, they tend to feel like it's a waste of time, for example, because they've passed grade 10. But you find that everything that we'll be doing for grade 10, they are not able to answer those questions. And most importantly, you'll find that those questions, they are a continuation. Like you find them in grade 10, grade 11, and also in grade 12. So they only want to do grade 12 stuff and they feel like they are complicated. Why? Because they did not understand the basics from the previous grades. So that is why most of you guys get a challenge when you get to grade 12. So my notes, all of my notes, I've incorporated grade 10, 11, and 12 stuff. So when you attend my masterclass, just know that you will be in good position because you'll be having the basics and all the information that you should know. So when you get to class, you will have a better understanding when the teacher will be teaching you guys. So maybe let's try and plot that one of y it's equals to tan angle, because I did got a response that you guys do understand all of that. So I'm just going to remove all of this. And then from there, let me say, let's sketch or plot y is equals to a tan angle, where the angle it is the element of still, let's say, 360 degrees and a positive. So from negative to a positive. Okay, here comes a question. How can we get the critical values for this function? What will that be?
It's 45 degrees, sir.
Someone is saying 45 degrees. Okay, you tell me, what is the period for this function?
It's 180, sir.
Yeah, so the period for the function of tan that's equals to a 180. So what is 180 divided by 4? Is it 45 degrees? If yes, then she is correct. So that means we are going to have to sketch something similar to that. And then let's do that. So if we have 90, 180, to that and that, here we have, let's say, 90, negative that, negative that, negative that. So she's saying our interval has to be 450. So that means we are still going to have a value there, a value there, a value there, and a value there, value there, value there, value there, value there. So if we have 45 degrees there, this is going to be 90. What will this one be? We just add by 45. So it's 45 plus 45, it's 90, plus 45 is 135, plus 45 is 180 there, plus 45 is 225 there, plus 45 is 270 there, plus 45 is 315 there, plus 45 is 360 there. Can someone mute their mic? Noluvo, can you please mute your mic? Here we've got negative 45, negative 90, negative 135, negative 180, what is that? Negative 225, negative 270, negative 315, and negative 360 degrees. Obviously there you can just be having your 1, 2, negative 1, negative 2. Let's say negative 1, negative 2. No, positive 1, positive 2, negative 1, negative 2. I'm not sure. Is everyone happy with what I've done over there? Does it make sense to everyone?
Yes, it does.
Should
Okay, then in that case, let's now try to make the points. So let's see. Obviously, we start from there going in that direction. Let's see. Turn into negative 360. What are we having there? I'm having 0 there. What about negative 315? Negative 315, I'm getting 1. There, I'm getting 1. And then let's get to the second angle being, what is it? Is it negative 270? Yes, negative 2. Hey, I'm getting error there. I'm getting, oh, okay. So everywhere it gives you error, guys, just do a broken line. Name. Everywhere it gives you error, plot that. So now let's go back to edit. 225, negative 225. I'm getting negative 1. I'm just not sure if you guys are also getting negative 1. Let's go to a negative 180 there. I'm getting 0 there. Let's go to this one of negative 135. I'm getting 1. I'm not sure. What are you guys getting? Are you also getting 1? I think so. 1 there. Let's go to this one of negative 90. Hey, I'm getting error there. Oh, okay, I just remembered. Everywhere we get error, let's do those. Wherever we get an error, let's do that. Let's go to negative 45 and see what are we getting. I'm getting negative 1 over there. I'm just not sure if you guys are also getting that. When you go to 0, I'm getting 0. Let's go to positive 45. What are you getting? I'm getting 1. You can just make a point there and say this is 1, this is 2. Then let me go to 90. Hey, I'm getting error. Remember, guys, you must be punching all of these on your side so that we check if we are getting the same thing. Let's go to what is it, 135. I'm getting negative 1, guys. I'm not sure if you guys are also getting negative 1. Let's go to the next point. Is it not 180? It is 180. Let's go to 225. 180 gave me 0. What about 225? I'm getting 1. There you can just plot your nice 1 there. Let's go to 270. What are we getting? Hey, this one is giving me 0, guys. This one is giving me 0. This is exactly what we are having over there. Okay, let's go and edit the next point. We are having 315. I'm getting negative 1 there. Let's go to the last point. I'm getting 0 over there. I'm not sure. Are we all on the same page on that one, guys? Am I not losing you there?
No, sir.
Last one to confirm. Okay, so if that is the case, let's then try to plot. Let's see. So now it's just a matter of connecting the dots. But remember, guys, your function, it just get closer to your asymptotes. It never cross, it never touch. It just gets closer to that. I remember during term 1, someone said the best way to explain in Zulu is to say our function is sondela, this broken line called an asymptote. In my language, I used to say erapalale yona. So by rapaling, guys, simply means that it gets closer and closer and closer and closer. It never touch, it never cross. Very, very much important, ladies and gentlemen, over there. So can you see here? It approaches that second point, and then from there, it gets closer. Then you continue, it must pass through that point, and then from there, it does that. Similarly, here, can you see? It goes to pass through that point, and then from there, iasondela. Same thing here, it has to pass through that point, and then iasondela. So, there from 0, and then it has to pass through there, then iazondela. I wanted to say, Kabelo, can you see that it's we can't really say this belongs to a certain grade, because your critical values are important in guiding in terms of how you sketch that. For someone who doesn't know the importance of the critical values, they were just going to have 90, 180, 270, 360, but they wouldn't know if here, because it's 180 is 0, they wouldn't know that from 0, does it go like this or does it go like that? Can you see? But because we understand the importance of critical values, we know that there's a point there where this is 225, and again there's a point there where this thing is 135. Then we know that it goes to approach that point, and then isondela lay that. From there, it goes to that point, and then isondela le that. Then it gives our function of tan a very nice shape over there. I'm not sure. Is everyone happy there? Am I not losing some of you guys on this one? Are you guys happy there?
Yes, sir.
Last one to confirm. Hey, Magazen, are you guys still there, or did you run away? Are you scared of this
Please
function,
do.
guys? Is it scaring you? Shravan,
No.
No, sir.
Likanya,
Yes, sir.
utugile lapho.
No, sir.
Okay, so now I hope everyone understands the basic procedure to follow when sketching that type of a function. So now what I'm going to do, let me maybe remove all of these and bring a clean whiteboard over there, because now I'm about to take you through a some theory part. You also need to be aware of this. Remember, guys, I've made some notes of which Mantua, remember to mute your mic. I'm just not sure if it's Mantua or if it's someone else, but it's fine. Just make sure to remain muted on your side. So there's something called an amplitude. If you have seen on my notes, amplitude. Some of you guys, you just know there's something called an amplitude. But now, an amplitude has got a formula which says an amplitude is equals to half of the maximum value and the minimum value. So as you go through my notes and you see this thing, saying the amplitude is actually equals to half of, let's say, the distance between the maximum and the minimum value. So it simply means that on your Cartesian plane, where, for example, you've got those critical values, and then let's say you've got 1 and 2, you've got 1 and 2 over there. Let's say for some reason, this is how your thing is making the shape. Just as an example. So this is 2, this is negative 2. I'm not sure. Do you guys agree with me that this point and this point, this is the maximum value? I'm not sure if you guys agree with me on that one. And this turning point below, it is the minimum value. So that means the maximum value is equals to 2 and the minimum value is equals to negative 2. I'm not sure. Does it make sense to everyone what I've just explained now?
Yes, it
Yes,
does.
sir.
Yes, sir.
Okay, so if you have to calculate the amplitude, you are going to say the amplitude is equals to half of the distance between the max and the minimum. You tell me, isn't it that the distance from there to there, is it not 2 plus 2 being 4?
It is, sir.
It is. So that means there you are having 4, which means the amplitude is actually equals to 2. Very, very much important, ladies and gentlemen, over there. So the reason why you need to understand this formula is because it's not at all the times where you will have your maximum being the same or almost the same value as that, but in opposite signs. Maybe let me do a very quick example over there and say, let's say maybe in some instances, you have your function, let's say, does something similar to that. Just as an example, guys, I know it's a funny sketch, but let's just assume that it is not funny. Let's say it's 1, 2, 3, 4. This is -1. So now, let's say there is 5 and here's 1, and the question may be saying, what is the amplitude over there? According to my formula, the amplitude is going to be equals to half of the distance between the maximum and the minimum. So now, what is the distance from there to there? Is it not, what is it, 5 plus that 1? Is it not 6, guys, the total distance? If that is the case, then it means there is 6. Then you punch this on a calculator, you have half of 6 being 3. So that means in case if the question says what is the amplitude of that, this is how you calculate it. Are you all happy there?
Yes, sir.
Wonke umuntu ujabulile bakithi. Libandla lakaNkulunkulu.
Sir.
Yes, sir.
Okay. So now I'm going to remove all of that. Let me move to the next part of the notes. So on my notes, I'm saying graphs of y is equals to that. So I'm saying the graphs of y is equals to a sine angle maybe plus q, and also that of y is equals to a cos of angle plus a q. They do have an amplitude. So that means all the functions of whatever or y, it's equals to sine of that, and again cos of that, they have amplitude. But for a graph of y is equals to, let's say, a tan of angle plus q, this function, it has no amplitude. I'm not sure. Are you guys getting what I've just said over there?
Sir.
Mm-hmm.
Yes, sir.
Okay, just to explain it, the reason to that is because, remember, for the function of cos and tan, even though I might not be accurate in sketching that, let's say we have something similar to that, and maybe this one, let me maybe do something similar to that. So can you see, for the function of cos and tan, they do have the maximum and the minimum values. That is why we are able to calculate the amplitude. Remember, the amplitude, we get it through using this formula which says half of the distance between the max and the mean. But now you remember the function for tan, you just have your what is it, broken lines there, and you might be having what is it, something similar to that over there. Maybe that or whatever. It doesn't really matter that much, but I'll just show you what I want you guys to be aware of shortly there. Can you guys see this thing? It continues, 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 it continues. Can you guys see that in this case, because it continues up to infinity, there is no maximum and there's no minimum. So that means there can never be an amplitude because we can't calculate that. That is why we say for these two graphs, we do have amplitude because they have the maximum and the minimum value, meaning we can use the formula to calculate. But for this one, there is no maximum, no minimum. Therefore, no amplitude can be calculated. I'm not sure. Are you guys happy there?
Sir.
Thulisile, uthulile lapho. Angazi ukuthi uyibona kanjani le ndaba le. Bofesesa, bothulisile. Bofesesa ukuthi ukotete yamini apha. Truza.
saying now we can understand.
Okay. So now, obviously, I did discuss to say on all of these functions, y is equals to, it could be a, whatever, it could be sine, cos, or tan, plus q. This one, it means upward shift. So, for example, if we had maybe let's say a parabola. When you say plus q, it means you shift it by whatever units upwards. Maybe if it is plus, let's say 4. If it's -1, there it's -2. 1, 2, 3, 4. So that means you shift it from there by 4 units upwards. So the turning point, it is no longer going to be there, but it's going to be at 1, 2, 3, 4. So that means it has shifted by 4 units upwards. So the same thing happens even here. When it's plus 4 units, it means you just take it as it is and you shift it by 1, 2, 3, 4 units, which means it might be doing something over there. Otherwise, if it's -3 maybe there, then it means you take it from here, you shift it by 1, 2, 3. Then it might be doing exactly that same change, but over there. Does it make sense, guys? I'm just not sure. Emmy, can you mute your mic, honorable member?
Oh, sir, I was saying blur so but now I can see clearly.
Oh, now you can see. Okay. 100%. But now, what I've just explained in terms of the P, does it make sense with it moving up and down being a plus P or negative P or minus P? Does it make sense?
Yes, it does.
Okay. 100%. So now, let me also explain something very, very much important, ladies and gentlemen. You see, let me just get a different marker there and see if, okay, let's say the graph of y is equals to a tan of angle maybe plus a q. You might need to remember that it has the broken lines called asymptotes at negative 270 and also at negative 90, positive 90, positive 270 degrees. I'm not sure. You did notice that, isn't it? Did you guys not notice that? You did notice that, isn't it? Those broken lines.
Yes, sir.
Okay, 100%. And most importantly, remember that when you sketch that, you should be careful of your critical values. And you remember the formula for CV is equals to the period over 4. And we normally know that the period is 180 degrees for that one of tan. Can you guys see? Solomon has got his mic unmuted. I'll just mute it from my side, but he won't be able to participate until the end of this lesson because I've muted it from. Okay, so now we end up having 45 degrees over there, meaning you space your function at intervals of 45. Just always remember that. I'm not sure. Do we move to the next part of our lesson for today, or is there someone who's got a question before I go deeper?
Oh,
We
sir.
can go deeper, sir.
Can someone say go deeper, Papa? Do you guys receive? Are you guys receiving there? Can I go deeper?
Yes.
Okay, so you guys do allow me to go deeper. Let me go deeper, guys. So the period, let me do this. Let me do this and say the period. I just want to give you a definition of what that is. So in short, the period, it is the interval over which the graph repeat its shape. That's what it's meant by the period. So the period is the interval over which the graph repeat itself. So we did notice that, for example, the graph of y is equals to a sine of angle plus q. And also for this one of y, it's equals to a cos of angle plus q. We did notice that it repeats itself after every 360 degrees. So that is the period for the sine and the cos function. I just can't really remember exactly how that goes like, but I think maybe let's say if it does something similar to that. So that means it is going to also do something similar to that. So can you guys see that from there up to there, it is the same shape as from there up to there. So can you see? It does that and then it also does that. It does that and then it also does that. And we know that from there up to there, it is actually 360 degrees. Also, from there to there, we know it is 360 degrees, but on the negative side of the Cartesian plane. So that's what we mean when we say after every 360, it does the same shape. After every 360, it does the same shape. After every 360, it was still going to do the same shape. So that's what we mean by the period. I hope you guys do understand that part very well. So let me just make a conclusion now to say for the one of y is equals to a tan of that plus q. This one is actually 180 degrees. So it's more like after every interval of 180, it completes its cycle. So you might find that, let's say maybe on a Cartesian plane of y and whatever there, here I think this is where this is 90 as a negative value and there as a 90 as a positive value. I think it does something similar to that. So in between you're going to have 180 and then you are still going to have another dotted line there where I assume it does something similar to that. Also on this side. So you will notice that this distance, what is it? I think it's a 90 plus another 90 is 180. The circle has completed. From 90 to there is 180 plus another 90 is 270. So I think from there to there is still another 180 degrees. So can you see the circle is completed? Also on this side, here it's going to be that. So that means it completes its circle. So it's more like after every interval of 180 degrees, it repeats the same shape, and that's what we mean by the period. I'm not sure. Are you guys receiving there? Libandla la kaNkulunkulu.
Yes, sir.
Is it everyone who's
Sir.
receiving there?
Yes,
Kinaki,
sir.
Yes.
what
Yes,
receive
sir.
for? Okay, 100%. Let me go deeper. Might need to remove all of this. I might need to remove all of that and check over there in terms of what is next. Maybe let me take you through the rules for sketching. Let me take you through the rules for sketching. So when you sketch rules for a sketching, so when you sketch this type of functions, for example, maybe we might need to sketch this one of f of x is equals to a sine of x. And again, let's sketch this one of g of x being equals to sine of 2x at an interval where x is the element of 0 degrees and 360 degrees. Let me firstly take you through the rules of sketching. So this is what I'm saying on my notes. I'm saying, firstly, find the period of the graph. Find the period of the graph. How do you find the period? The period is equals to not necessarily the period, but the critical values. I think that's what I meant to say. Let me remove all of that. Obviously, we do know what the period is for that function. What is the period for that function, guys? Do we know? Magaizen, are you still there? Guys, isn't the period for y is equals to sine x equals to 360?
Yes, sir.
Yes, it is 360 degrees. But can you see, the moment
Sir.
you start having a value in between the trig ratio and the angle, then the period is no longer a 360, but there's a way in which you calculate it. You just say the period it is going to be. You know that the period for this function is 360. So that means for this one, it is going to be 360 because you know for sine angle is 360. But because of that too, you just divide it by 2. What are you getting? You get 180 degrees. So it's more like if you have something in between, of which that can be represented as, let's say, maybe a sine, maybe bx. Can you see? You now have the b value. So that means the formula for calculating the new period, it is going to be, you know, for sine is 360 degrees, then you divide by b. If maybe you are given y is equals to cos of bx, because of the b value, it means the period it is going to be still 360 divided by b, because you know that the period for cos and sine, both of them are 360. But maybe for this one of tan, remember, for this one of tan, we know that the period is going to be, what is the period for tan function?
180.
100%. It's 180 degrees. But because of that b value, it is therefore going to be 180 divided by 2. So, for example, if you have tan 2x, y is equals to that. That means the period for this one, it is therefore 180 degrees divided by 2. What is that? Is it not 90? So that means the graph repeat itself after every interval of 90. For this one, what will the period be for that one? How are we going to calculate the period for sine 2x? Okay, this is the formula. The formula says is p is equals to the period for sine. Is it not 360, guys? What is the b value there? Is it not 2? So that means the period is now 180 degrees because this divided by that is equals to this. Does it make sense, guys?
Yes, sir.
Okay, so if we are given y is equals to, let's say, cos 3 theta, what will be the period for this one?
So
Sorry? Can you say V?
360 degrees divided by 3.
Why 360?
Yes. Yes, 360 divided by 3. What is that? Is it, what is that? Is it 60 or 45? What is that? Let's see. 360 divided by 3 is 120.
120 degrees.
So that means this is now the new period for this one. So what will be the critical values for this one having that period? What is the formula for critical values? Do you still remember?
Period divided by 4.
Yes, is the period divided by 4. So if you know that the period for this function is 120 degrees, so that means you're saying you're going to say 120 and then you divide it by 4. What are you getting there?
3 degrees.
What is it? 30?
T.
Let
It's
me just
30, sir.
120 divided by 4. Yes, it's
30
30.
degrees.
So that means when you sketch your function, you must space it at 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30. Are you guys happy with discovering how to plot the function using this CV formula? Is everyone happy there? Mm?
We're happy, sir.
Okay. So now,
Yes, sir.
let's see. If you can check on my notes, I hope you guys did see the notes which are sent in the library. So, I did say investigate. What is it? Sine x and also sine 2x. But just to conclude on the rules, guys, just so that we are clear or we are on the same page. What happened to my markers? Are you guys stealing my markers? Someone is stealing my markers here. Maybe let's try this one. Let's try this one. Okay. So these are the rules. The first thing that you need to do is to try and determine the period. And we know the period is equals to, if it's for sine or cos, then you know is 360 degrees divided by b. What is b? B is this value in between the trig ratio and the angle. What is the b value there? Is there someone who can guess what is the b value there?
Answer.
Sorry?
Answer.
Druza is speaking, but I'm not able to hear what he's saying there. Did someone hear what Druza is saying there?
Saying it's one, sir. One, sir.
Yes. He's saying
1.
1. So there is an invisible 1 there. That is why for sine angle, it is actually 360 divided by 1, which is equals to 360. So that means for sine angle, for cos angle, it is just 360. So if it's 2 there, you divide it by 2 and you get whatever answer, which in that case is 180. The next thing that you need to do now, but remember guys, this is for sine and cos, but for tan, you know the period is 180 degrees over b. And then it obviously depends on the type of a function that you'll be dealing with. So now, the next part that you need to do is to therefore try and find your critical points. We know that the critical values is equals to, what is that? It is the period, you just divide it by 4. So that's how you get your critical values, and then from there you can then do that, and then you just punch all of that on a calculator based on the critical values. And most importantly, you must know from where to where. So can you see? Let's investigate this and that. We just want to see how does that function having 2 in between look when you compare it with that one. Let's maybe try to draw. Can you see? I can just Somar do this. I know my function. Hey, what can with my markers there? Okay, maybe this one is better. So I know that I'm going to start from 0 and then go in that direction. So I can just say y. There I'm having angle. What is that angle called? It's called x. So that is x. So since I'm sketching these two functions on the same set of axes, I'm going to use the critical values of this function and not that of this function, because for this function it is going to be, for example, 90, 180, 270, then 360, but I need to accommodate that function on my thing over there. So what is going to be the critical values of g? Is there someone who can tell or revert as that? My chance. Bantwana bakaNkulunkulu lisasekhona lapho or
I
libalekile?
think 90, sir.
What did you say, honorable member?
90.
She's saying 90. How did you get to 90, honorable member?
I said 360 divided by 4.
Or maybe, what is the period of G? Okay. I still need to explain this part of getting the critical values. So remember, guys, when you find the critical values, this is what you do. Remember, the first thing is to determine the period of a function. What is the period of that? Remember, this is f of x is equals to a sine of angle, and this one is for g of x is equals to sine 2 angle. The period for this one, it is going to be, period is equals to a 360 divided by 1. There's an invisible 1 there, which is equals to 360. That means CV, it is going to be this 360, which is the period you divide it by 4, you get 90. So that means the critical values for this function, it is these ones which are spaced at 90 degrees, 180 degrees, 270 degrees, and 360 degrees. What about for this one? You must first determine the period. What is the period for that one? Is it not 360 divided by that 2 over there? What is that? Is it not 180? If it's 180, this is the formula for the critical value. It says period over 4. What is the period for that? You just calculate it as 180 degrees. You divide it by 4. What is that?
45.
Someone is saying 45. I'm not sure. Do you guys agree with that one? Do
45,
you
sir.
guys understand it better now?
Yes, sir.
Yes, sir.
Is it everyone who's understanding it better now?
Yes, sir.
Yes, sir.
Sir.
Okay, so that means to accommodate that function in between, you must still have 45. You add 45 is 90, you add another 45. What is that? You add another, you add another. What is that? What is this plus 45? Let me see. You just punch on a calculator. So it's 90 plus 45 is 135. Plus 45 is 180. Plus 45 is 225. Plus 45 is 270. Plus 45 is 315. So can you see? You just have everything at an interval now of 45. Here is 0 degrees. So that means both of these functions will be accommodated in here. So now let's catch this one of sine angle. It's sine 0. You start from 0, it gives you 0, you make a point. Remember, this could be your point 1, maybe this one negative 1. So point, what is it? Sine 0 is that. Let's go and add it and have 45. For 45, you're getting 0.7 as a decimal. So you can just say it's something, maybe it's a positive 0.7, maybe somewhere there. Then you go to this one of 0.7, maybe somewhere there, yes. You go for 90. For 90 is 1, then 1 it is there, and then you go to this one of what is it, 135. 135 still the same, 0.7 whatever as a decimal, and then you go to 180, it's 0 there, and then now you go to that one being what is that, 225. You are getting negative 0.7 somewhere there. You go to that one of 270, I'm getting negative 1, which I can make a point there. You go to that one of 315, I'm getting a negative that, and then you go to this one of 360, that is 0. Then all that you do, it is just to nicely plot that. You might need another marker there. Let's see. I'm just not sure if you guys are able to see how nice that is. And then from there, what does it do? It goes there, and then it joins that one, and then from there it goes there, and then it goes to join that one. I'm not sure. Can you see how nice that is? Are you guys receiving there? Libandla la kaNkulunkulu. La ikwishisha. Batho ba bomma la ikwishisha go.
Yes, sir.
Yes, sir.
Okay, so now in that case, let's maybe quickly try to sketch this one of sine 2 angle. So how you sketch it, you just punch it to say sine of 2 inside the brackets. You have your angle. You can start at 0 there and say 0. If it gives 0, it gives 0. You can just make a point there at 0. Hey, what's happening to these markers? I need some new markers there. Let's see. Let's maybe try that red one. Okay, there's a point there. Let's maybe go and edit this one of 45 and see what are we getting there. That one of 45, it gives 1. And there's 1. Remember, this is 1, this is negative 1. Maybe let's go and edit and use that point being 90. It gives 0 there. And then let's go and edit again. Remember, this is what you should punch. It is sine of 2 into, then you do 2 brackets. All that you do is just to edit that. So I started from 0 degrees, I got 0. You go to 45 degrees, you get a point. You go to 90, you get a point. Now I'm on that one. What is that? This is 135. I'm getting a negative 1 over there. I'm going to the next one being 180. I'm getting a 0 there. I'm not sure. Can you guys see that with this one already it has completed its circle within that period of 180. This is the graph of F, and this one, it is the graph of G. I'm telling you guys, if we continue with this one, remember from there to there, the period is what? It's 180, which is that 180 there. So what I'm saying is, if we try to continue and plot it again, it might still do that, whereby here you are having a 1, and then there you are having 0, and then there you are having negative 1, and then there you are having 0. Because I know that its period is 180. So that means after every 180, it is going to repeat itself and do exactly the same shape. So if you punch a what is it? That obviously we've seen is that if you punch that, it is going to give you 1. If you punch that, 0. If you punch that, that. Times that is 0. I'm not sure. Are you guys following there? Do you guys understand what I'm trying to explain over there?
Yes, sir.
Yes,
Is it
sir.
everyone who's getting what I'm trying to say over there?
Yes, sir.
I'm telling you guys, this chapter, it is a bit tricky, but in order for you guys to have a better understanding of this chapter, that's when we do more of this type of lessons. The main aim is for me to complete today's lesson so that I know that tomorrow we focus on answering exam type of question papers. Maybe let's do last part of our lesson so that we know you guys might be ready to then go through the journey of answering exam type of question papers, which is what we'll be doing starting from tomorrow. Okay, so maybe for the last time, let's try and sketch the function of y is equals to, let's say, cos of 3 x, and then the interval, that's where x, it is the element over 0 degrees and 120 degrees. I'm not sure. Is there someone who wants to explain to us in terms of what will be the critical values of that function? Are you guys still cabanging there, or you've got no idea?
Say, I'm not sure, ne? But I said 120. I divide down 4, ne? Then I said 120 divided by 3, it gave me 40. Yeah, angazuthi yona na.
Okay. Let's say for you to determine the critical values, you completely don't focus on that. So this one, it simply tells you that on your horizontal axis, you must start from 0 and then end at 120 degrees. That's what this thing tells us. So we are just not sure in terms of by how much are we going to space our function there. Maybe let's say here we have 1 and then here -1. So for you to know, that's where you calculate for the critical values. So the moment you see cos, you know the period for cos, or the period for the formula, is P is equals to, you know that for cos, it is going to be 360 degrees divided by B. If it was tan, it was going to be 180 degrees divided by B. Let's say this is for tan, this is for cos, and also this is for sine. So that means the period for that, it is going to be 360 degrees divided by what? By 3. What is that?
20.
20, sir.
120. Okay. If it's 120, then our CV, we know that is equals to 120 degrees divided by 4. What is that?
30 degrees, sir.
No, sorry guys, not 180, but 120, because the period for this function you guys are saying is 120. You see, this is 120 and not 180, eh?
Yes.
Okay, so
It's
what is
30
that?
degrees, sir.
So this is 30 degrees, ne?
Yes, sir.
Okay, so in that case, it means you are going to space your whatever by 30, 30, 30, 30 until you get to that. So let's say maybe it is going to be 30, 60, what is it? I think maybe I might need to just make that. So you might have said, I'm not sure what's speaking, you might have said, you said 120 divided by 4, but you did not explain if this 120 is coming from there or if it is coming from that calculation. If you did explain, I was going to confirm for you, but because I saw that 120, I thought maybe you took it from there. But just remember that maybe on your next explanation next time, explain from this part if you meant your 120 came from this calculation and not just saying maybe 120 divided by 4, because we're no longer sure if it comes from there or if it comes from a certain calculation. So let's see. So that means we are going to have let's say a 30, 60. After 60 is what? 70, 80, 90, and then 90, 100, 110, 130. So I think it is going to end there. So that means we've got 30 degrees, 60 degrees, what is this? 90 degrees, what is this? 120 degrees. This is our x value. Okay. I just want to quickly get my power bank, guys. But in the meantime, can you guys try to plot all of those? Plot it on your paper there, and then from there, you'll just be giving me what are the points at each critical value. I'll be back in less than a minute. So in less than a minute, you guys should be done. Are you guys done? It's been 4 minutes now.
Not see.
Are you still busy punching?
I'm so busy.
Just make sure not to break your calculator there, guys. Thabile, usasekhona lapho Ntombo?
Isekhona, sir.
Ilwa Ntombo, ilwa. Chinaki, kuhamba njani lapho? Lebogang, kuyasebenzeka lapho. I see Sibusiso wants to comment. Sibusiso, it's unfortunate You were muted because you couldn't control your mic. I've been requesting that you mute it on your side, but you did not. So if I mute it from my side, you won't be able to communicate until the end of the lesson. So that means you can only be able to participate on the next lesson. Is there someone who's done? Not yet.
We're done, sir.
Okay. Whoever's done, what are you getting at 0? Mind you, overlekile.
I think it's 1, sir.
She's not sure. Okay. She's not sure.
It's
I'll just
1.
punch it from my side. Okay, I'm getting 1. Remember, the moment you say you think is 1, hey, I'm starting to have some doubts. You don't sound confident. I'm getting 0 there. You need to be confident, guys.
I
If
think
your
it's
calculator
1.
said 1, just say 1 and not mention
It is 0.
I think, guys, because the moment you say I think, it means you are not sure.
120 is 1.
Then we are having that. I'm just not sure if this is exactly what you guys are having there. It's really not that complicated, guys. Then we have that. I'm not sure. Did you all guys get the same thing over there?
Yes, sir.
Okay, 100%. So now,
Yes,
let's
sir. I
quickly
got the same thing.
answer these questions. Sorry, what is the amplitude there? This is question number 1. In exam, they might say, what is the amplitude there? Hmm? Okay, I'll answer the questions. So the amplitude, remember guys, the amplitude we said is half of the distance between the max and the minimum. So that means it's half of 1. We know this is 1. This is the maximum value, plus the minimum value there we can see is 1. So that means 1 plus 1 is 2. What is half of 2? Is it not 1? So that means the amplitude is 1. Obviously, the maximum value, it is that 1 being 1, and the minimum value, it is that 1 being negative 1. And then when they say, what is the period? The period, you calculate it as you know, for cos. The moment you see cos, you think of 360 as the period. But the moment it has that b value, then you divide by b, meaning what is this? What is that? Is it 120? I think it's 120 degrees. So that means the period is 120
120,
degrees
sir.
over there. So yes, it's 120. So it seems like all of us got the same thing. So I want to give you this information as parcella, guys. I'm just not sure if you guys know what parcella is. Tabile, do you know what parcella is? Emi, do you know what parcella is?
I
You
do.
guys don't know parcella.
So,
So parcella is more like bonus. You know, when you buy something, especially what is it? Mochofatsela. For those of you guys who come from Limpopo, you know exactly what Mochofatsela is. Do you guys have a better understanding of what a parcella is?
Yes, sir.
Okay, so since I've explained to you that when you have a y is equals to, it could be a, doesn't matter whether it's sine, is cos, or is tan. The moment you have plus q, this q value tells you more about the vertical shift. The vertical shift means the upwards or the downwards shift. So here comes a parcella, guys, the horizontal shift. So this is exactly what I want you guys to be aware of. All matriculants should open their ears together with grade 11. So for grade 10s, this information you don't need to worry that much about. So the horizontal shift, that's when, for example, you have y being equals to, maybe let's say for sine, you've got your angle there. Let me maybe use angle theta so that it makes perfect sense. It's theta, and then you end up having a value there. So that means for cos, you're going to have a, what is it? Cos of angle plus p. Otherwise, for tan, you are going to have something similar to that. Just so that it makes sense, it could be, let's say y is equals to sine of angle, maybe they say plus 30 degrees there. I'm sure you've been this type of questions. You have that maybe minus a, what is it, minus a 45 degrees there. Or otherwise you have y is equals to maybe the angle, let's say plus 60 degrees over there. I'm sure you guys have seen this type of questions before. Let's now maybe explain this one, which says y is equals to, if for example you've got sine, let's say x, the moment they say a plus 30, it simply means your function has been shifted by 30 units to the left. If it's a plus there, it means it has shifted to the left. But the moment, for example, you have a cos of, let's say, a beta there, and then we have negative 60 degrees, then it means it has shifted by 60 units to the right. So that means when you have a negative there, it shifts to the right. And the reason to that is because you take the whole of this thing and you equate it to 0. So you have that equals to 0. So that means you've got x is equals to, you transpose, you have negative 0 degrees. So can you see it moves to the negative side of the angles, or to the negative side of that Cartesian point. So if, for example, you have something similar to that and it shifts by 30 units, then it means it is no longer going to start there, but it is going to start at negative 30 there, at that negative 30 there. So that means it is going to do something similar to that. You just take it exactly as it is, then you shift it. So if it's a negative 60 there, if you take this and you equate it to 0, you've got your angle being beta, what is it, beta minus 60. Then when you transpose, you end up having your angle being equals to positive 60 degrees. So that means it is no longer starting at 0, but it is starting at let's say 30, 60. Then it starts from there, and then it does that. Then it ends there because it shifts by 60 units to the right. I'm not sure. Matriculants, did you all get that?
Yes, sir.
Can I get some amen there if someone understood what I
Yes, sir.
was explaining there?
Yes, sir.
So it's everyone who understood that part, isn't it?
Yes, sir.
Okay. Then in that case, ladies and gentlemen, this brings us to the end of our lesson for today. I'm just not sure if there's someone who's got a question on whatever that I've spoken about in today's lesson. Is there someone who's got a question before I sign up? Is it no question, Your Honor?
No further questions.
Questions.
Ladies and gentlemen, thanks very much for joining. My name is Desmond, and I'm out.